Algebra 1 skills number 21, graphing linear inequalities in two variables. Okay, so here's an example of what we're talking about. We're not talking about a one variable case here where you're just isolating x and graphing on a number line. We're talking about on a Cartesian coordinate system. So as if you're graphing a line using slope-intercept form or using standard form. So let's graph this example that we see. Here's the technique for doing that. First, you want to draw the points needed to draw the line. Okay, so you'll put those on there without drawing the line at first, though, because you either make the line dashed or solid depending on if you have the or equal to option. Okay, so if you don't have the or equal to option, you're going to dash the line. If you do have the or equal to option, you make it solid. And we'll explain why when we see an example. And then this third step, there's different ways of doing it, but a safe way would be to place a point, such as the origin, into the inequality. If the origin works, or whatever point you choose works, shade towards the point. If it doesn't, shade away. And again, we're going to see an example of that here in a moment. Okay, so here's y greater than 2x minus 1. The same example that we had saw earlier. So we're going to graph this. It's in slope-intercept form. So again, your y-intercept here is -1. Your slope is 2 over 1. Okay, so you can see those points. We're going to connect them with a dashed line. Now, the reason it's dashed is because of this greater than symbol right here. It's not underlined. If it were underlined, you would make it solid. Okay, so we connect with a dashed line. Now, the reason for that we'll see for our shading. We're going to shade actually this way. Now, there's different ways you can think about that. The step 3 that we had presented earlier is to place the origin there. The origin you can see is right here. The origin is 0, 0. If you put 0 in for x and 0 in for y, that's going to make a true statement because 2 times 0 is 0. 0 minus 1 is -1. And 0, which you place in here also, is larger than -1. Okay, so you would shade towards the origin. Now, some may look at this and say, well, it's greater than, so just shade above the line, and that works. You have to be careful sometimes with that, but that does work here. But either way, you do shade on this side. Now, why is it dashed and why? What does the shading mean exactly? Well, when we graph something, the shading indicates where your solutions are. Okay, so anywhere in this green area is a solution. If I choose, for example, native to 2, this point, it will work if you place it in there. So anytime you ever graph something, what is shaded is a solution. The reason we dash in this case is the border itself is not a solution because you're missing that or equal to option. Anything along the border is going to make each side be the same. Well, if you can't be equal, then that means the border is not allowed. So we dash it to show that. We need it to graph a region, but we dash it to show it's not a solution. Okay, so look at this second example. So here we're in standard form, so it might be easier just to cover up or put zeros in to get your intercepts. So to get my y-intercept, I put 0 in for x. So if I put 0 in for x, this part goes away. You have 4y equals 8, basically. You can pretend like it's an equals when you graph it. Divide by 4, it gets 2. And to get your x-intercept, pretend like that part's not here. 2x equals 8, divide by 2 to get your 4. Now this time it's underlined, so you're going to connect with a solid line. And this time it's below. Okay, so you're going to shade down below, or like the step 3 put that we put on there. If you put 0, 0 in there, it's a little easier to see here. If you put a 0 here and a 0 there, it's going to be 2 times 0 plus 4 times 0. That's just 0. It's less than 8, so you shade towards the origin. Third example. This time it's x only, okay, but it's still intended to be a linear inequality in two variables, even though you don't have the y. So this is a graph on a Cartesian, not a graph on a number line. So x only would be a vertical line at -4. It's dashed because, again, you're not underlined. And this time above and below have no meaning because it's a vertical line. Of course, x greater than, you would shade to the right. Or do the origin trick. The origin here would only require you to put 0 in for x, and 0 is greater than -4. Now, coincidentally, all 3 of my examples were shaded towards the origin, but you're 50-50 on that. Sometimes you do shade away from the origin, so just I don't want you to think you always shade towards the origin. Fourth example, are the following solutions to this? Okay, so we're not going to focus on how to graph it because we've already done this. This is repeat number one. We're going to focus on a different kind of question here. So here's the graph we got from number one, and we're going to have this purple point, this black point, and this orange point. And you see their locations on there. Okay, let's go to the next frame. The question is, are they solutions? Well, the purple point is clearly within the shading, so yes, it's a solution. The black point is clearly outside the shading, so no, it's not a solution. But the orange point is exactly on the border. So again, the dashed is significant here. Because it's dashed, that means it cannot be a solution there, so it's not. Had that been a solid line, the answer would be yes to 4C. Fifth and final example, a boy wants to earn more than $2,000 over the summer by mowing lawns and working on a farm. He earns $50 a day mowing lawns and $75 a day working on the farm. Write and graph an inequality to model this situation. So maybe this is the case here to where you would think, well, just always work on the farm, you make more money, but maybe you can only work certain days on the farm, or maybe working on the farm is harder labor, or it takes longer. So he wants to mix it up, work some mowing lawns and some working on the farm. So an inequality for that would be, well, first let's label. X would be the number of days mowing the lawn, Y would be number of days working on the farm. This would be your inequality. 50X is the amount of money you make working X days mowing lawns. 75Y is the amount of money you make Y days working on the farm. Together, you want more than 2,000. You don't want exactly 2,000. You want more than. So here's our inequality. Okay, we're going to go ahead and graph it. And again, here the cover-up method, or putting zeros in for each, is probably best. The x-intercept would be 40. The y-intercept would be between about 26.7. Notice we went by fives here. And you don't really need anything negative because that wouldn't make sense. We're talking about numbers of days you need to work. And what I've done is put some orange dots on here just to explore the meaning of this. This would be the only one that would work for him, which would be, remember, X we said was working mowing lawns. So if he worked 15 days mowing lawns and 20 days on the farm, that would be enough. That would get him more than 2,000. Now, if he worked 20 days mowing lawn and 10 on the farm, that would not be enough. 25 mowing lawns and 10 on the farm would be exactly 2,000. You have to work another minute somehow to get that. Okay, so this is a little bit on graphing inequalities.